Welcome, sixth graders, to lesson 6, session 3 on page 119. Yesterday we found the greatest common factor. Today we're going the opposite direction. Instead of going factors, we're going multiples. And we're doing the least that they have in common, the least common multiple of these numbers. We get to start out with a cute little sheepy over here. Our try it says Morgan and Ann own North Country sheep farm. Morgan shears one herd of sheep every 6 months. One herd of sheep every 6 months. Ann decides to shear another herd of sheep every 8 months to see if waiting longer results in higher quality wool. She's getting fancy. Both herds are sheared this month. In how many months will Morgan and Ann shear their herds in the same month again? So they shared in the same month again. They're not going to overlap for a while. Let's see how many more months it's going to be until they overlap again. So we're going to list the multiples of 6 and 8, not the factors. We're looking for the least common multiple this time. And this is very handy if you have a multiplication chart in front of you. You can just look at the multiples of 6, which are, let's see, what was the multiple song that I was teaching my students? If you had me last year, you've heard 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and 66. And then for the 8s, I like the 8s, it has clapping. Oh, I can't clap and okay, I'm gonna slap my phone for my clapping, right? 8, 16, 24, 32, and 40, 48, 56, right? 64, 72, and 80. Yay. Okay. I need to practice those again. Okay, now I'm looking for the least number they have in common. That's going to show us the next time that they're both sharing the sheep together. How many months it's going to be. Well, they don't both have that or that. They don't both have 12. They don't both have 16. They don't both have 18. Oh, they both have 24. It's going to be 2 years. 24 months from now. Or 2 years from now. So when they model it, they did what we did. That's the same thing. Or you can use prime factors of two numbers to find their least common multiple. 6 and 8 have, they just did the factor trees, they did the factor trees, I guess, again? Yeah. 6 and 8 have a 2 in common. And you multiply the factors of the numbers. So, if they have it in common, you only use it once. That's the dealio here. So this is the one they have in common, so they combined it, and then they put the rest down individually. So, these, they just put one time. You can't overlap it. And then that 2 is there, that 2 is there, the 3 is there. You multiply all those together. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. There we go. That's a fun method too. Number 1. The numbers 24 and 48 are common multiples of 6 and 8. What do these numbers represent in this situation? Okay, well 24 was the next, how many months it is till they shear the sheep together again. And then 48 is double that. So I guess that would be the next time, 4 years from now. So those would be the next 2 times they shear their sheep in the same month. Assuming that they keep up with that same pattern that long. You know, maybe the sheep wool quality isn't good and she gives up on the experiment. Number 2, both model it show that the least common multiple of 6 and 8 is 24. What does the LCM, the least common multiple, represent? what was it? Months? How many months? Until the ladies shear their sheep together once again. I hope they're not lonely in the meantime. I hope they still hang out. Maybe get a pizza together. Number 3, why is the common factor 2 used only once? So to go back to refer to what are we talking about? So when we have prime factorization of 6 and prime factorization of 2, they have 1, 2 in common. So we only used it one time down here and then used each of the rest on their own. Why? Why would we do that? I'm going to give you a much simpler answer than the teacher's book has. If they share the factor, you don't need to use it twice. If you use it twice, you would just get, I don't know, the number would be too big. That number would be double. It would be 48. That's not the least common multiple. That's the second to least common multiple, and that's useless to us. Number 4, the product of 6 and 8 is a common multiple of 6 and 8. So remember the product. What is the product of 6 and 8? The product of 6 and 8 is 56. No, 54. What am I thinking? 54. There we go. But it's not the least common multiple of 6 and 8. Look at the statements about the least common multiples. Underline the LCMs that are the product of the two numbers. So sometimes the least common multiple is the two numbers multiplied together. Which one is it? Okay, the least common multiple of 4 and 5 is 20. The product of 4 and 5 is also 20. So that's one. Oh, it says underline. I guess I'll underline. Fine, be that way. Underline the least common multiples are the product of the two numbers. Okay. The least common multiple of 4 and 6 is 12. Is 4 times 6 12? Nope. It's 24. The least common multiple of 4 and 3 is 12. Okay, yes. 4 times 3 is 12, and their least common multiple is 12. The least common multiple of 4 and 8 is 8. Well, the product of 4 and 8 is 32. And 32 is not 8. They're not the same number, so no. When can you multiply two numbers to find the least common multiple? So what do these have in common? They're not all even. They're not all odd. They're all small. 8's pretty small. 6 is pretty small. What factors do they share? What factors do they share? 4 and 8 share a factor of 2 and of 4. 4 and 6 share a factor of 2. 4 and 5, the only factor that they share is 1. 4 and 3, the only factor that they share is 1. When the only factor they have in common is 1. There we go. So we listed out all the factors for 4 and all the factors of 5. The only factor they'd have in common would be 1. But if we listed out the factors for 4 and 6, their common factors would be 1 and 2. That doesn't work. Okay, number 5 is for you to do. Think about all the models and strategies you have discussed today. Describe how one of them helped you better understand how to find the least common multiple. Pause and then come back to me to practice. Okay, time to practice. Number 6. Maria is buying plates and cups for a party. She wants the same number of each. Plates are sold in packs of 8. Cups are sold. I'm going to highlight that. Plates are sold in packs of 8. Cups are sold in packs of 12. What is the least number of plates and cups that she can buy? A common problem, also known as the hot dog problem, because hot dogs and buns are sold in different quantities in their packaging. So let's see. Plates are sold in packs of 8. Cups are sold in packs of 12. Remember, we can do this two different ways. We can either list all the multiples of 8 and all the multiples of 12, and see. Let's do it that way. So 8, 16, 24, 32, and 40, 48, 56, 64, 72, and 80. There we go. I don't have a song for the 12s. Sorry. 12 times 2 is 24. Oh look, we're already done. I don't have to keep going. Ta-da. She would have to buy 24 of each. Hopefully she has at least 24 friends coming. Or maybe not. Maybe they need extras. Who am I to say? I'm not judging. Number 7. You can judge me though, because apparently I can't read numbers. Number 7. In problem 6, suppose that Ria wanted at least 40 plates and 40 cups. Okay, she is having a big party. Could Ria buy exactly 40 plates and 40 cups? Well, she could buy 40 plates. That's the wrong color. She could buy 40 plates, but can she buy 40 cups? I guess I do have to keep going, don't I? 24, 48's the next one. Is 48 a multiple of 12? No, it is not. 48 is not a multiple of 12. Okay, last one we're doing together. Ooh, snacks. There's too much food going on in this page. It's making me hungry. I want to go to a party and get some free burgers from Joe's. When Carlos goes to his favorite restaurant for lunch, he gets a sandwich and a smoothie. Ooh, he's got good taste. This restaurant has 2 rewards programs. Buy 10 sandwiches, get 1 free sandwich. Buy 4 smoothies, get 1 free smoothie. I want to go to this place. 4 smoothies, get free one. How many times does Carlos need to buy a sandwich and a smoothie to get both of them free on the same visit? Show your work. Well, least common multiple. I guess I should do it the other way just to show you how to do it. So let's do 10. Let's do the prime factorization of 10. 10 is 2 times 5. Oh, look, they're already prime. That was fast. And then 4 is 2 times 2. That was easy enough. Okay, what do they have in common? They have a 2 in common. That means you only use that 2 once. And then use all the extras. So 5 and 2. 2 times 5 is 10. 10 times 2 is 20th visit. Okay. That's it for our practice together. You have your green pages to do on your own. Good luck.